Welcome to Beginner's Breadboards, my electronics learning journey. Today we're looking at making a current mirror using BJT transistors to control LED brightness. So what we have on our circuit is three separate and distinct branches, each with their own transistor. We're using the 2N222 NPN BJT transistor, and then we also have a supply of 5 volts. So on this first branch, we have a 0 to 10K potentiometer. And we also have a 330 ohms protection resistor. And with this transistor here, we're linking the collector and the base together. So the base emitter voltage is the same as the voltage on the collector that's being controlled by the 10K potentiometer. And so by changing the voltage that's here, we also limit the amount of current that's able to flow through here. And because both of these other transistors on the other branches are getting the same voltage on the base and emitter, they're also getting the same current that's flowing through each of the 3 branches. And so by changing the voltage here, we're limiting the current, and that can control the brightness of these 2 LEDs. So pretty much the current in all 3 branches are equal to each other, and then the current of branch 1 is equal to, it also takes into account the current that has to flow through the base and emitter of both of these transistors. So the reason we're using a 330 ohm protection resistor is because this can go to 0 to 10K, and because these LEDs are limited to 20 milliamps, that's their maximum, by having a 330 ohm protection resistor here, we limit the total current of the system to 12.87 milliamps on each branch, so that's more than enough to protect each of the LEDs. So with the 330 ohm protection resistor, the voltage on the base emitter will go to a maximum of 0.75 volts, and so about approximately, not exactly, and so using the total of 5 volts minus that amount of voltage divided by the 330 ohms, that's how we get this number of the 12.87 milliamps for the maximum amount of current, and that's just an approximation based off of what the transistors approximately do. And then for the current, the first branch's current is the current of the collector as well as the base, and it also takes into account the current here on BE for Q2 and Q3, whereas the current on the other 2 branches is only the collector current for both of those LEDs. So here's everything built on the breadboard. So this is the 10K potentiometer. This is the protection resistor, those 330 ohms. And this is the first transistor. This all makes up the first branch. And then the other 2 branches are the red LED and the second transistor. And then the third one is the blue LED and the third transistor. We're also having our meter here to measure the current on that single branch. That's part of that third branch. So we're also using a 5 volt supply here to power the whole thing. And so we don't need protection resistors for these 2 LEDs because the entire current of the system, or the current of each branch, is mirrored from the resistance on the first branch. So there's no need for a resistor on these 2 LEDs. So now this is set at right now the highest resistance, but as we move the potentiometer, the LEDs will begin to glow, and then we can also see that there's a reading here on the meter, so we can increase that, and there will be more current that flows as the resistance of the potentiometer is decreased. And now we can see that it maxes out. And that'll keep going, and now the LEDs are glowing at their full brightness, and this goes to right around 12 milliamps. And then we can see that the reading on this meter is about triple what we're seeing from one branch, because there's 3 branches. There will be 3 times the current in the entire system. So this is measuring one branch, and then this is measuring the entire circuit. now we can go back the other way. The LEDs will stop glowing.